Magnetars are the most magnetic objects in the known universe, born from the collapsed cores of massive stars. Imagine a celestial object so powerful that it could wipe every credit card on Earth from halfway to the moon. A magnetar is only about 20 kilometers or 12 miles wide, but it contains more mass than our entire sun. Its magnetic field is 1,000 trillion times stronger than Earth's magnetic field, which is powerful enough to dissolve your very atoms if you got within 1,000 kilometers or 620 miles of its surface. Welcome to the extreme world of magnetars, the most dangerous stars in the universe. Today we are investigating the extreme physics of these strange remnants, diving into the most intense magnetic fields ever discovered by modern science. Space is filled with bizarre and terrifying objects, but few can match the sheer destructive capability of a magnetar. They lurk in the dark corners of our galaxy, spinning rapidly, glowing with intense radiation, and occasionally erupting with bursts of energy that can be felt across thousands of light years. To understand how such a monster comes to exist, we have to look back at the life cycle of the most massive stars in the cosmos. Not every star has what it takes to become a magnetar. Our own sun is far too small. When a star that is at least 8 to 20 times more massive than our sun reaches the end of its life, it runs out of nuclear fuel. For millions of years, the outward pressure of nuclear fusion balances the inward crush of gravity. But when the fuel runs out, gravity wins instantly. The core collapses inward at a fraction of the speed of light, crushing the atoms so tightly that electrons and protons are smashed together to form neutrons. This sudden collapse triggers a massive shock wave, resulting in a supernova explosion that blows the outer layers of the star deep into space. What is left behind is a dense, incredibly hot sphere of pure neutrons. This is a neutron star. A typical neutron star packs about 1.5 times the mass of our sun into a sphere, just 20 kilometers or 12 miles across. The density is almost impossible to comprehend. A single teaspoon of neutron star material would weigh about 1 billion tons on Earth, which is roughly the weight of Mount Everest. But a magnetar is not just any neutron star. It is a very special, very rare variant. Out of the thousands of neutron stars we have discovered, only a few dozen are confirmed to be magnetars. What sets them apart is their unimaginably powerful magnetic field, and the secret to that field lies in the exact moment of their birth. When a massive star collapses, its rotation speeds up dramatically, much like a figure skater pulling in their arms to spin faster. Some newborn neutron stars spin hundreds of times every second. At the same time, the newly formed core is violently churning with convective fluids, acting like a giant cosmic dynamo. If the spin rate and the convection match up perfectly, they can amplify the original magnetic field of the star to astronomical levels. Earth's magnetic field is about 1 Gauss. A refrigerator magnet is about 100 Gauss. A standard neutron star has a magnetic field of about 1 trillion Gauss. But a magnetar has a magnetic field that reaches up to 1 quadrillion Gauss. This is the absolute upper limit of magnetic strength in the known universe. The magnetic field of a magnetar is so intense that it fundamentally alters the physical properties of the vacuum of space around it. According to the laws of quantum mechanics, empty space is never truly empty. It is boiling with virtual particles that pop in and out of existence. A magnetar field is so strong that it forces these virtual particles to behave in strange ways, causing light itself to split and polarize as it travels near the star. This effect, known as vacuum birefringence, was once only a theoretical prediction, but astronomers have now observed it in the light coming from a distant neutron star. What would happen if you somehow found yourself near a magnetar? The danger would not just come from the crushing gravity, though the gravity is 100 billion times stronger than on Earth. Long before you even reach the surface, the magnetic field would destroy you at a fundamental level. At a distance of 1,000 kilometers or 620 miles, the magnetic force would begin to overwhelm the electromagnetic forces that hold your atoms together. The electron clouds that orbit the nuclei of your atoms would be stretched into thin, shaped like needles cylinders. The chemistry of life relies on the specific shapes of molecules, but near a magnetar, all molecules are distorted beyond recognition. The bonds between atoms would break, and your entire body would dissolve into a cloud of elongated subatomic particles. Even water, the fundamental building block of life, would become a highly toxic, strange substance under these conditions. But the danger stretches much further than 1,000 kilometers, or 620 miles. As mentioned earlier, if a magnetar were placed halfway between the Earth and the Moon, roughly 190,000 kilometers, or 18,000 miles away, its magnetic field would instantly erase every magnetic stripe on every credit card, every computer hard drive, and every piece of magnetic storage on our planet. It would scramble the navigation systems of airplanes, disrupt the communication satellites, and cause massive electrical surges in our power grids, plunging the entire world into a dark age. Magnetars do not just sit quietly in space. They are highly active and incredibly violent. The surface of a magnetar is a solid crust made of a dense lattice of neutrons and exotic particles. This crust is constantly subjected to immense stress from the overpowering magnetic field inside the star. The magnetic field lines are twisted and tangled by the rapid rotation, building up an unbelievable amount of tension. Eventually, the crust cannot handle the strain anymore, and it cracks. This event is known as a starquake on Earth. Earthquakes are caused by tectonic plates shifting, releasing energy that shakes the ground. A starquake is conceptually similar, but the scale of energy released is beyond human comprehension. When the crust of a magnetar cracks, it sends a sudden, violent jolt through the magnetic field, snapping the magnetic field lines and releasing a colossal burst of energy in the form of X-rays and gamma rays. These eruptions are known as soft gamma repeaters, and they are among the brightest explosions in the universe. A single flare from a starquake can release more energy in 1/10 of a second than our sun will emit in 100,000 years. The sheer power of these starquakes was vividly demonstrated on December 27, 2004. On that day, a wave of gamma rays washed over our solar system. The radiation was so intense that it blinded several space telescopes and physically altered the upper atmosphere of Earth, causing it to expand. Astronomers quickly traced the source of the blast. It came from a magnetar known as SGR 1806, located about 50,000 light-years away, or roughly 300 quadrillion miles away, on the other side of the Milky Way galaxy. Despite being incredibly far away, the flare was brighter than the full moon in the gamma-ray spectrum. It was the brightest event ever recorded originating from outside our solar systems of deep space. Thank you for watching. I really would appreciate it if you would subscribe, follow, like, and comment, as this helps the algorithm know that people are interested in my videos.